Hi, I'm Julian, and I'm one of the co-founders of Design Create Play. And tonight I'm going to be talking about our experiences working with Node.js and how we use Node.js to build our product called NodeBB. So, I was actually supposed to be speaking with another person here tonight, but he's actually out of the country, so I'm going to do this by myself. Yeah, I'll give it a try. That's fine. Okay, so NodeBB is our one of our products that we're developing right now, and it is essentially we've taken everything that has worked well with forums for the past 10-15 years, and we've essentially distilled it down to its essence, and we release it as new forum software using Node.js+Redis as a data store and Socket.io for two-way communication. So what I'm going to try right here is that we've actually set up a NodeBB instance. So I see a lot of you have tablets or smartphones and so on. If you want to go to DevTO.NodeBB.com, what will happen there is you'll actually go to a NodeBB, and if you have any questions you want to ask me midway through my presentation, you can actually just write it down as a forum thread, and I can actually get to it at the end of the presentation. So if you have to raise your hand or whatever, right? So that's devto.nodeb.com. Right, so in this presentation, I'm going to talk about some of the lessons that we learned while using Node.js, some mistakes that we've made, and some pitfalls that we've avoided. So we've been working with Node.js for I suppose past 3-4 months, and we've actually learned a lot since then. It's been a really great platform to work with. Lesson 1 is to not reinvent the wheel. So Node really follows the Unix philosophy of doing one thing really well, and to write programs that work really well together. So when we're talking about that, this is, for example, this is our dependency list on NodeBB. And actually, this is a little old, actually. I think our dependency list is about twice this size now. But what this looks like here is all of these individual products are actually standalone Node.js programs, and we sort of slot them in sort of like modules, and we can use them without having, and we can actually cut our development time by half or thirds. Basically, we don't have to spend all this time developing frameworks and reinventing the wheel to do something that lots of people have already done. So for example, we have Redis, we have our own database abstraction layer already built for us, or Passport, so we can do Facebook and Twitter integration in minutes rather than hours or days. Decrypt, so we can encrypt user passwords and so on. ImageMagick, so we can resize user avatars. Less middleware, so we can program in less as a preprocessor and output CSS. Or even just email handling, which makes handling email so much easier. And the main takeaway from this is that it's probably better than anything you can do yourself, because it's got hundreds of man hours put into this software to make sure that it's bug-free and security-free, and it's free open source, so you can make sure that you know what you're getting, and you're probably not going to have bugs and edge cases that you run into. The next lesson is Node's hybrid client server model. So the main part of Node is the fact that it has JS at the end of it, which means you have JavaScript. So JavaScript on the server side, coupled with JavaScript on the client side, means that it really gives meaning to the phrase JavaScript everywhere. When you have JavaScript on both sides, you can even share libraries, you can share config files, and it really just enhances code reuse, and then you don't get lots of unnecessary code duplication. And we really use this to good effect in NodeBB, where instead of having to, we have our own file called the utils class, and instead of having to manage one version of it on the client side and having another version of it on the server side, we actually put it into one file and we share it, and we only have to update one once. The next lesson is that Node.js is non-blocking by nature. And when I say non-blocking, I mean that it uses the event loop to avoid idling. So typical threads, and has anyone here used, have done any server administration of any sort? A little bit. So you know what I'm talking about. I'm talking about threads and processes. For the most part, a thread will idle when waiting for a request to complete, but Node.js really takes advantage of that and makes sure that it doesn't idle any more than it has to. So it will not idle as long as there's something to do. So do we have any JavaScript people in the crowd tonight? Yeah. So most of you have at least touched upon JavaScript or have seen JavaScript or something like that. So right here, the second argument in this method is a callback. And a callback, put simply, used normally, is to denote a set of actions that you do at some later point. For example, once one routine is finished, we'll call a callback and then run something else. And what Node does is, when that callback is set, it defers execution, but instead of waiting for, let's say you're making a request to a database, for example, and instead of just idling while the database returns row data, they'll just go on and do something else. And this is where the real scalability of Node comes in. So typical calls that can take a long time. You have, of course, database calls, or Facebook API calls that can take 2-3 seconds on a good day, if you're lucky, right? Image processing, which resizing images or adding filters to images like Instagram does, can take time. Or file I/O, like writing data to disk or reading data from a hard drive. So all of these things, usually you would offload to another process. And what Node will do is say, okay, my event loop says I need to go and process this image. I'm going to offload to image magic. And while it's doing that, I'm going to go and do something else. And so then that single thread ends up being able to do more than a single thread in a typical, say, PHP. So this leads into lesson 4, which is that Node.js is single-threaded. There's one thread to rule them all, which is a little bit counterintuitive because you think more threads, more scalability. A lot of server admins, for example, will try and do this sort of black art where they tweak the number of threads and processes so they can get as many concurrent users as they can. Because typically, one thread means one server. To put simply, one thread is one user on your website at the same time. But so it's a little counterintuitive to think that Node has, just one thread. But because of the event loop model, you can handle more users at the same time because you can do more with that one thread. Put simply, and a lot of people will think of that and say Node.js is single-threaded, but it's actually a bit of a myth because down into the core of Node, it actually does manage its own thread pool. So it does do some tasks in parallel. So it is not technically single-threaded, but for all intents and purposes, the main event loop is single-threaded. So let's try an analogy here. We have 3 different processes. We have a washing machine, we have a dryer, and we have the folding of clothes. So all of these contain some sort of blocking action. Let's say I'm washing my clothes, I need to load my clothes into the washing machine. And this requires my full attention, but once I press start on the washing machine, I don't have to do anything else. A typical thread would, of course, hit start on the washing machine and then just wait there, staring at the washing machine while it finishes washing clothes. Whereas in Node, it wouldn't happen like that. So, in typical server architecture with PHP, for example, let's say we have 2 threads. We would start the washing machine, and then we'd idle for a bit, and then we would dry some clothes, and then we'd idle for a bit, and then we would fold the clothes, and then we'd idle for a bit. For the sake of argument, let's say folding clothes, you have some idling. In Node, because instead of idling, you go ahead and do something else, because let's say the finishing of washing clothes is inside of the callback, let's say. In Node, what we can do is actually just keep throwing things into the washing machine as long as our washing machine to throw stuff into. So you can see there's no idling happening here because Node will think, okay, I'm going to load the washing machine, and I'm done with that. And while it's running, I'm going to load another washing machine, and a third washing machine, and so on. And basically, you can handle more than a typical server. And lesson number 5 is to know when not to use Node.js. So a lot of tech leads and CTOs will think, okay, I'm going to go with Node because it's a be-all, end-all. It's a silver bullet, and it's going to solve all of my scalability problems. But really, this is not a good idea because if you don't know, if you don't use Node properly, it's actually not any faster than any other server architecture. So there's some good uses for Node. Let's say you're building a game, for example. There's lots of two-way communication, lots of long-running processes and HTTP requests. But typically, an HTTP server isn't quite optimized to work with long requests that a lot of these new real-time two-way games, these new games can take advantage of with lots of two-way communication. So Node really excels in that because it really turns the whole idea of an HTTP server on its head. Scaling CRUD apps is really, really easy. But a bad example of using Node would be a very CPU-heavy application. So let's say we're doing image resizing or adding image filters, adding filters to an image. But doing that completely through Node.js would be a blocking operation, for example. If you don't offload it to another service like ImageMagick or whatever Instagram uses. If I were doing it all myself, Node.js would essentially dedicate its one single thread to, say, resizing the image or what have you. And then if it takes 5 seconds, for example, that's 5 seconds where you're not serving information to the customer, right? So this is not that would not be a good example of something to put in Node. Lesson number 6 is that Google is V8 powered. Not V8 the vegetables, but I mean V8 the JavaScript engine. Which is great because as a web developer, I've gone through my share of, can I actually use this method? No, because IE6 doesn't support, or IE8 doesn't support, or something like that. But I don't have to worry about whether there's Internet Explorer, or whether I'm working with old versions of Mozilla, because you only have the one JavaScript engine to worry about. And because V8 is pretty standards compliant and pretty complete, I don't have to worry about whether I can use a function or a method or not. Lesson number 7 is actually dealing with callback now. So if you've worked with JavaScript for any long period of time, you've worked with callbacks, and you've noticed that the more callbacks you do, and the more callbacks you nest, the more it looks like that, basically. So if you add 1 or 2 more, eventually you end up scrolling horizontally more than vertically, which is not a good thing because you really kind of lose where you are in the code. So that's, in this particular instance, you have a typical morning routine. You wake up, you brush your teeth, you get dressed, you eat breakfast, you feed your dog, and then you go to work. For the most part, for the sake of argument, let's say all of these have to be done in the order that is put here. That's why I have them all in callbacks. Yeah, that's why I have them all in callbacks, so that they execute in the right order. So it's probably a better way to do that, let's say how it is. Wouldn't it be much better if we could just sort of jump onto a single line and say, let's just run these in series? And that's where the npm package async comes in, which is my favorite package in Node.js so far, because we can actually just say, let's run them all in series, and if there's an error, it will handle it. Otherwise, it will go to work. Otherwise, it's just right? And the async package actually does a little more than just running in series. It can even run things in parallel, or it can run an iterator function on a collection of arguments, like an array or an object or something like that. And that's where the power really comes in. And lastly is Node's error-first convention. So if you think back to how you've interfaced with APIs in the past, how you handled errors, some APIs will send back a false, some APIs might send a 0, some APIs might crash, some APIs might send a JSON string with the specially handled error argument that you have to parse. But the main thing is all of these are different, and you have to handle them in specific ways. But Node really champions the fact that you have to use an error-first methodology because it just makes a little more sense if everybody's using the same way of reporting errors. So in this particular instance, you'll notice that the callback function, that first argument is an error. What happens is if there is no error, that's fine, we just send it to null. But if there is an error, we put like an error object or a string or something in there. Basically anything that's not false, it's constituted as an error, and we handle it as such. Right. So then the real power comes in if you are nesting lots of callbacks. If you have 5 callbacks nested deep, and one of them errors out, we can actually bubble that error up through the chain, and we can handle it gracefully on the client side as opposed to crashing or terminating the process, which is definitely not something you want to do, especially with Node.js. Do we have any questions or comments?